So last time what we talked about was playing like blinking lid on hexaware and do some very easy serial thing on our hardware. Today I will try to cover mbed interrupts and timers. So how many of you heard about interrupts before or timers? Okay, good. Interrupts in hardware or did you hear about interrupts in hardware like that? Hits like that? Okay, good. I will go through as if no one know anything. I will accelerate if I found you in a good shape. So if we have a teacher and we have a bunch of students who are sitting and the teacher is just going through his slides and then a student asks a question, this will what will happen? The teacher will stop the main going through the slides or the board or whatever, and then go to answer the student question and then return back, right? This is normal thing in the class which you can see. So at time 3 the teacher will say, okay, he will stop now for describing and then he will answer the student question which may be related or not related. Then at time 5 he will say, okay, where did I stop? And let's continue from where I stopped. Okay, this is in real life. Everything in programming has to make logic. So this is the logic. So the same thing in programming and embedded systems, it has to follow the logic. So let's see now our mbed. If mbed is running the main loop, which is the while one, running forever something, and suddenly some interrupts came on one of the pin, something happened, either software interrupt or hardware interrupt. So same thing, at time 3 it will leave the main loop and go to execute another function which may be related or not related, no one knows. And then after finishing executing that function, it will return back to the main loop, right? So as mbed is not a human, it's a machine, right? So we have to program it and make sure that it goes through this logic in a good shape. So what will happen? At time equal 3, the mbed will save the state of the main loop. What I mean by state, for example, he was executing at line 10 in the code. When he goes to execute an interrupt and then return back, he has to start from or to continue from the same line, right? And also there is some variables that has to be saved. You cannot every time start from scratch. The teacher, if you ask me a question, I will not every time start as if it's from 0, right? So I have to save the state. This happens in human as I have brain. So we have to program the mbed to do the same thing. Then at time 5, the mbed will recover back the saved state and continue executing. This is called context switching. This concept of context switching is not only in mbed, it's in OS. How many of you heard about this context switching? Okay, good number. So context switching as a high level thing, it means two processes are running, one process is running, then you would like to switch to another process. So you have to save all the states here in the main loop or the main process before going to the other process, so that when you come back, you can continue executing. This concept of this called context switching. It happens in OS, multi-threading, everything, and it happens, of course, in mbed. By the way, how many cores this mbed has? How many programs can run on the same time? How many? First, when you open your laptop, you are running, for example, Word, MATLAB, some browser, Firefox. Does that mean that all of them are running on the same time? No, right? What happened? What happened? But as a user, you see all of them running. Exactly. The server are giving tiny amount for everyone. As a user, you will not notice. You may notice when when you open a lot of things, heavy stuff, then you will notice some delay. Same thing here. It's only one thing running. On your laptop, you may have multiple processor, and you can have 3 or 4 running. But here it's only one. So we have main loop. This is the loop which is taking the processor. And if we would like to execute something else, we have to pause and then go execute and then return back. We don't have option of running 2 things. So the teacher did the context switching, right? When he returned back, he continued from the same point. We have to make sure that mbed is doing the same thing. The library or the mbed OS will do the job for you. You don't need to do this as a programmer, right? So, and now what will happen if I have multiple students asking one question at the same time? For example, two students raise the hand on the same time. Okay, if this happens now, what I will do? As a logic. Think, when you program, you have to put the logic first. If you see some programmer goes direct to the code, something is wrong. He has to have the logic first. So this is the logic. So now, assume 2 of you raise their hands. What the teacher will do? I will think, for example, I will go, okay, let's go right to left. Or maybe I will say, you already asked the question, let's take his question. So I have some logic, I am thinking, I have brain, right? So the teacher may go alphabetically, or he can think and give answer for each student. Also, here you have 2 interrupts or 2 new process. You have the main loop, which is the main slide, and then you have 2 questions. And every question, think about it as a separate code, as you will not ask the same question 2 times. So for example, he will ask me, what's UART? And he will ask me, what is Canvas? The answer will be different. So I have to get 2 parallel processes here, right? But again, I cannot run 2 things on the same time, so I will do this context switching. So how many context switching I am doing here? How many context switching I'm doing here? Yeah, but actually here, as they came on the same time, I will maybe finish his question, and I don't need to save anything, as I will not return back, right? And then I will go to the second student, and then go back to the main loop. Now let's go to the mbed machine. What mbed will do if it got 2 interrupts and 2 bins, for example? Until now, how many of you didn't understand what interrupts mean? What do you think? What interrupts mean? Yeah. Yeah, it's from English. I am interrupting you, right? You are working on your laptop, and I interrupt you. So I ask for something to do now, right? So it's interrupting. I'm interrupting you. So same thing here. If mbed got 2 interrupts, for example, in 2 bins, mbed usually have some priority for the interrupt. Some of them are high priority. It has to be executed first. For example, I say, for example, this student didn't ask before. Let's answer his question first. So I'm giving him higher priority. The same thing will happen with mbed. Mbed will assign priorities. The default will be equal. Then he will choose anything according to the code. Yeah, the function which is called to be executed is called the interrupt handler. How many of you know what interrupt handler means? Okay, still good number. I hope you survive until the end. So, until now, I need you to have some concepts and add it to your ROM. I don't want you to forget these concepts for the whole life. So, first concept is interrupt handler. Interrupt handler means the function which will be executed when interrupt happens, right? And this is the definition. It's a code which is associated with a specific interrupt. So now, anyone can help with defining context switch based on my slides. Context switch. Exactly. It's like organizing, saving the state of the current thing and then go to the other process to be able to continue back. All of you are good in terms of context switch? Okay. Anyone can help with interrupt vector? I didn't say it before. What's interrupt vector mean? Okay, there was 7 surviving. So, will anyone of the 7 who knows what interrupt means? What's interrupt vector mean? Exactly, but how to choose? How this is in low level happens? You are as a coder writing some text as function. How this will be executed here? Exactly. Exactly. There is a memory for the code, right? And there is memory for saving the variables. And this memory of the code has address for each line. So interrupt vector is like the address of the interrupt of the handler. And then interrupt vector table, it means the table of addresses. For example, if someone fire interrupt on bin number 1, which code should I run? How this will happen? For example, let's take this example. I have 2 interrupts on this hexaware, one on bin 1 and one in bin 5. How to know which code to run? Exactly. Anyone else can help? I have interrupt on bin 1 and interrupt on bin 5. And I have 2 functions for each interrupt, right? Yeah, you are talking about configuring the interrupt. I assume now that everything is configured, life is good, and let's see what mbed will do. I have function 1, I have function 5, and then interrupt on bin 1 happens. How mbed will choose the right function? This is my question. Which address? Okay, very close. Anyone else can help? Exactly. So, right answer is, or very like correct answer is going to the vector table. If the interrupt happens, the mbed will go to the interrupt table and then see, okay, this is interrupt number 1. I have to go for interrupt number 1 row and pick the function which corresponds to interrupt number 1. Then execute that function. Everyone is good here? What do you think? I will keep pinging you as you said the last one at the end. What do you think? Yeah, and don't worry. I was in your place and I didn't understand many things and I was interrupting the teacher. So do the same thing. So my question is, I have function function 1, some code, and I have function 5, some code. Okay? And then this function should be executed if interrupt happens on pin 1. And this function should be executed if interrupts happen on pin 5. This is the logic. For example, if you ask me what's UART, the UART definition is in function 1. If you ask me what's CAN bus mean, the CAN bus definition is in function 5. Now, you ask me what's UART, or you ask mbed, who doesn't have brain, how mbed will choose the right function to execute. Okay, forget about the answer. Try to repeat the question. What's the question? Just say anything, don't worry. Yeah, try to clarify more. I have 2 bins and I have 2 functions, right? And they have to execute one function if the interrupt happens on 1 bin, right? And I am asking how the mbed will choose the correct function to execute. This is the question. Do you got the question? How it will know? For it, it's like a processor has binary code. Okay. Anyone can help? I know you just joined. Do you understand or? Okay, so do you understand the question?
So we're trying to figure out how to choose between the 2 functions.
Yeah, you have function to execute whenever some interrupt happens. You have corresponding function for each interrupt. How mbed will choose? I am a teacher, I have a brain, I can think and give you the right answer. How mbed will choose?
So does it go to, as somebody said, go to first value the vector table, and then that'll tell you?
As a programmer, yes, this is correct. As a programmer, you have to configure this vector table to tell mbed, see, if interrupt happen on bin 1, execute function 1. So whenever any interrupt happens, the mbed will go to this table and find the correct address to execute. Do you know what I mean by correct address to execute? Usually you deal with address as a data.
So we have bin 1 to 5. So we have 5 to row and
Yeah, I have just 2 bins, bins number 1 and bin number 5, and they have
1 to row and
yeah, exactly. And mbed is trying to choose the correct function to execute. Yeah, I'm asking now what this controller unit will do. It's here it's not a complex thing, it's just low-level embedded programming. So I'm asking how mbed will choose. He just responded. Can you repeat the answer? Did you got the answer?
For computer, there's zero and zero, and then according to the zero, they go to the correct address and execute the process on zero.
Exactly. So as a programmer, you have to fill this table. And this table will write, okay, function 1 correspond to bin 1, and this bin 1 correspond to some address. Go to this address and execute the code at the address. Okay, now another question. What does executing code at address mean? We usually deal with memory for data.
Well, the function that at some address.
Yeah, there is a part of the memory which you cannot fill with your files or whatever. When you install MATLAB, when you install any software, it goes to some part of the memory for executing the code. This is the code memory. You cannot put data there. All the addresses which I am mentioning is in the code memory, right? So everyone is good? Are you good? Okay. I know you came late. Are you good or? Okay. So I was spending so much time here because these are very important questions. I would like, if I meet any of you in 10 years, where you have children and babies, you can answer these 4 concepts. So there is concepts that you will learn and you should not forget. This is for everything. It's for OS, for programming, for job. It's a shame if someone asks you what's context switch mean and you cannot answer. Okay? So you can forget anything in the class. You can forget me, forget my name, forget everything in the class, but don't forget these concepts. And bring me whenever you didn't understand anything, okay? Okay, now I will go through how to create an interrupt, and then, what's the time? You are my timer. What's the time?
25.
I have remaining 25 minutes? Okay. Okay, I will go through quickly the steps, then I will give you time at the end to do yourself on the hexaway. So here I am trying to make a new program as we did last time on the browser. So I will make a new program, and this, after the new program, this project content, it will have the mbed OS. It will have a one main file. CBB is C++, and some README is just some text. And if you would like to add a driver, I described it last time. Drivers, OS drivers is like to configure the low-level stuff to be able to use them, as you don't need to. This is like the APIs. The APIs are defined in these drivers, right? Or in top of mbed OS. So if you would like to add a driver, you have to choose import, as I am doing here, and then write the driver which you need here in the search place here, and then click import. And this is the project content. The driver will appear here. Now here is a simple interrupt, like applying the concept which I was saying. So the interrupt here is super simple. I would like, whenever I push a button here, the LED toggle. So what's the interrupt handler here? The interrupt handler. The function which will be executed when the interrupt happens. What the function will have? You don't need to look at the code. Just have the logic first. Toggling the LED, right? Is this toggling the LED will go forever? Exactly. So the main loop will not toggle the LED. The teacher job will be describing something, and only if you ask me, I will do the action. So this toggling lid will happen only when the interrupts come to mbed. Okay? So how to write this? This is the main which will be executed. You will have, here I just write printf, hi something, it doesn't matter. Here I am attaching something and giving it address to some function. It's like filling the vector table, the interrupt vector table, right? I'm telling mbed, look, if you got interrupt on this bin, go and execute this function. Right? Who is, anyone have any problem? Any problem until now? Clear for you? Okay. So I just, this is what's attached bottom up. What's attached bottom up? I didn't define it. Anyone can help? It's an API. It's an API, right? We defined last time, we spent a lot of time describing what's API. You remember the dash U and the department example. The department asked the dash U to admit the students. The dash U will do a lot of job to do the admission and return with the status. It's the same thing here. I am telling mbed, see, just attach this code to this pin. Fill the vector table. I don't care how the driver will do it as a programmer. I don't know. I'm describing it to you, and I'm not sure how this API is implemented. Yeah. You know, in C++, I think most of you talk C++, this at means address, right? So I'm giving it address to the function. Right? So whenever the interrupt happens, go and execute this function. Are you good? Yeah? No, every button will have a specific API in this library. Every library will define its APIs, right? Who wrote the library? It's some engineer, right? And he just make it like that. Who said that ECE should say admit student and then give the quarter? This is like a protocol, how to do it, right? So it's the same here. The API is defined as attach, and then this is bottom up. It's like one of the button on the hexaware. And then I'm saying if the interrupt happens on this button, which attached to a pin, go and execute this toggling lid. I think I have the figure here. Yeah. So I run it at home and I took figure. So here, okay, not sure how, yeah, it's like that. So here, yeah, my finger is much bigger. So now this is I think most of you has the hexaware, right? This is bottom up. This button. These are buttons, by the way. They are touch buttons. It doesn't look like a button, but it is a touch button. So when I toggle this lid will turn on and off. And this lid is BTA12. It's written on it BTA12. That's why I wrote here I wrote here BTA12, you see? Okay, what's lid underscore BTA12? What's the difference between BTA12 and lid underscore BTA12? Exactly. So I can replace lid BTA12 with your name or my name, Amr. I can write here Amr and write here Amr equal not Amr. This is the name which I'm giving, right? And here this is something defined on the .h. So it's like defining int x in C++. You did that before, right? Okay. So you can now keep interrupting. Whenever you interrupt, it will keep toggling. It depends on the definition of the API. Every API should have some corresponding description in text. So what do you mean by filtering here? Multiple times, for example. I think most of them are smart enough to do this. Yeah, I think this one is stable. I tried it and I keep interrupting and annoy my embed. And I think it's good. Okay. Any other question? Okay. So in the sorry? You are asking here? BT. This one? Yeah, I'm not sure about. I'm not sure about this. I can check it for you. But this is how to include or instantiate the driver. I think it's like bunch of bins or something. I'm not sure. So when I say timers in this embedded device, there is time when I ask him what's the time now, he will say, what's the time now? Yeah, what's the time? 3:30. This is like UTC or whatever, Los Angeles time, right? So now in embed, when I say timer, it's not like the UTC time. Timer in embedded system means counter. Okay? So it's like the stopwatch. Does the stopwatch tell you it's 2:30? No, it's just counting, right? So it's something like that. You are counting on one hand, and 0, 1, 2, 3, 4, 5, and then you reach here the overflow level. It's the maximum. I don't have the 6 fingers, right? So it will overflow and start from the beginning. 0, 1, 2, 3, and so on. This is how timers goes in low-level embed. All your BCs don't have this 230. It's based on something like that. Of course, it's not 5. It will be 32 bits, 64 bits, so it will count for long numbers. I'm just giving here trivial examples. So again, now what's the difference? What timer means in my controller? Can you help? What's the difference between timer and embedded system? Okay, you are answering my question, or this is, yeah. So yeah, I am asking what's the difference between timer and the time which I am asking him about. This is 2:30 UTC stuff. It's number of seconds, number of minutes. You know, when you Google time now, it will give you. There's a lot of websites tell how many seconds from the start of the year. Something like that, right? So this second and minute is just a protocol for us to deal. But everything is based on counters. There is some transformations on top of counters to have this minute. For example, if I know that I am counting with a rate 1 second, I can just have a for loop or whatever. Whenever this 1 second reach 60, make minute equal minute plus 1. This is a simple transformation to go from counters to real time. I know it's a confusing name to say timers, but this is what timers mean in embedded systems. What do you think? What's timer mean? Embedded. Yeah. It's based on clock which goes up and down, and someone is counting the rising edge. If you go more deep, someone is counting the rising edge and doing this 1, 2, 3, 4, 5. Right? This is what timer means. So mbed OS or mbed drivers make timers here super easy. You can just instantiate or define timer T as I did here, and then mention T to start the time, and then wait for 2 seconds. Wait is a API, which will let him wait for 2 seconds, doesn't do anything, just idle wait. Then stop the timer. Then here I am reading the timer value. So what do you expect this printf to do? To print on the terminal? 2 something. If it's accurate, it will be 2 zeros, right? If it's not that accurate, it will have 2 point something, right? So this is, I showed you last time how to configure the terminals. How many of you played with terminals on home? Okay, okay, no problem. You can start playing, as most of you got the hexaware. You have to start as we will ask for assignments which use terminals. It's very easy as I did. You just connect it like that and choose the port number, and you will have a terminal. If you are using Beauty, it has some extra job to do, which is again super easy. So this is what's printed out of my program. So it prints the waiting time equal 2 seconds something. It's not that super accurate. Okay, I modified my code now and make it like that. Anyone can tell me what the output will be? Sorry? There is no button here at all, right? Okay, one is suggesting, okay, let's vote and see who would win, okay? So one is suggesting 2, 4, 6. Any other answers? And so on, right? It will not stop, you mean, right? Why? Because the while one, right? Yeah. And anyone can suggest another thing? 2, 2, 2. Okay? Okay, let's see. How many here and how many here? Can you raise your... Okay. You don't have a lot of supporters. Only. And what about 2, 2, 2? Okay. What about the idle people? What do you think? Don't cheat and try it. Yeah, just kidding. So which one do you suggest? This one? Okay. Yeah, this is the right answer. When I ask you this question, you tell me this is a stupid question. You should tell me what the description of the API before this. You are giving the discussion section for the first time. I don't know about this. How are you asking this question? Right? So this is how the answer should be, right? The correct one is this. But I'm not saying that these people are wrong. It's my mistake because I didn't define for you the API. Okay? So it will do this crazy stuff, 2, 4, 6. So now I think you can answer now why it has this. Why it's this one, not this one. It's not resetting, right? It's like a stopwatch on your phone which you buzz. It's like a buzz, not a stop, right? So all of you are good? So the API name is very stupid, which is stop. It should be called buzz or something, right? Exactly, but yeah, this is correct. This is my second slide. I added here t.reset. Now it should do 2, 2, 2, 2, right? So it will be like that. Okay? It's not? It's seconds. You can No, it's second. The API definition is second, and you can see it on your watch. It's really second. It's not perfect, but it's close. Okay, now what about asking the mbed to do periodic task? I would like to wake every day at 6 a.m. and do something and take breakfast. I would like mbed to trigger me and prepare, for example, if it's home automation, whatever, prepare the breakfast for me. How to do this? Sorry? But the interrupt doesn't have sense of time. Exactly, this is a correct answer, to have both. Interrupt and timer, right? But then you have to say, interrupt me when this time elapsed. So it's not interrupt, this is called software interrupt. I can call it software, it's not a good name, but I think, as I mean by hardware, something on the bin from outside. It's like software, it's something counting inside. It's not a correct name, as timer is already hardware also, but yeah, just let's call it like that. So, mbed OS and drivers make something called ticker instead of the timer. And they use this ticker to let you define something which is keep repeating like that. This is how I define it. So you define ticker 1, as I did here. And this is the lid. And then I am saying, you see, I am attaching now to the ticker something close to the interrupt, but it's a ticker now. This ticker is a timer. It has time sense. It's not bottom or something. It has time sense. So I am saying, see, when 2 seconds elapse, go and execute this function. Okay? This what will happen. It will keep executing some function when this interrupt fire. So anyone can expect what's the output of this program? Okay, so this is the first answer. Someone do that. He said this is on for 2 seconds and off for 2 seconds. Anyone suggest another thing? And does it repeat or only once? Okay, one say it's only once. What do you think? This is not my mistake this time. I already defined for you the API. It's something that's keep repeating. Okay, so it will not do one time. It will keep forever. Okay, so now this will keep executing every 2 seconds forever. So it will keep going like that. 2 seconds here, 2 seconds here. And this is on here and this is off here. Here? It has nothing to do here. It's a MBT code. Yeah, something to wait. Okay, I'm not doing anything. Normally, it's not like that. You will have complex code, and you are using the interrupt just to interrupt you to do something on a specific time. Here, it's a simple hello world. Yes. Sorry. If I don't have this main loop. I didn't try it on this hardware. I tried on another microcontroller. It goes in a wrong address space, and it will not execute anything. I didn't try on this hardware. If it's smart, if the OS is smart, it will do this embeddedly. I think it will not do it, but I'm not sure. We can try. But I tried on another ARM and everything. If I remove this, it will go to the wrong address space, and everything will stop working. So here I'm keeping it in a good address space. Any question?
So just to confirm with you, it will come into main, do the printing, as soon as it speaks to
Yeah. Yeah, this is a good question. What about moving this line to here? What about moving the attach to the while loop? Does it make sense? Yeah, the vector is already attached one. Who will delete it? Why you need to keep saying x equal 1, x equal 1, x equal, it's already x equal 1, right? You don't need to do this. Yeah, if x, yeah, if x is moving somewhere and you would like to reinitialize, of course, but here no one is missing your table. Sorry? It should work. It should work. As I'm not doing anything, I'm just saying x equal 1. Here? No, if I move it here? No, here I'm not saying lid equal 1. I'm just filling the interrupt vector table. Right? What this attach means? I'm saying the mbed C, if this interrupt happens, go and execute this function. And I keep repeating the same information for him. I hope it stays silent and didn't say any bad words to me. As this is very stupid, I'm saying the same information so many times. He already knows. This code? It's the same as doing while 1 x equal 1. Does it, if I do x equal 1 here and x equal 1 here, does it matter? You are just executing stupid.
Does it reset the timer?
Sorry?
Does it reset the timer every time you attach it?
I didn't try it myself, but I doubt it will be stupid API as I'm just attaching. But maybe you are right. We can try it. I'm not sure about the exact description, as usually the documentation of APIs doesn't go deep in all these special cases. So it will be high level description. So you have to try yourself. So I cannot answer these corner cases, right? Unless I'm expert, super expert playing with this for forever. And I am not, okay? So it will keep toggling. If I remove the while loop, I think, yeah, I tried this, not an embed. If the OS is smart, it should handle this. On my other experience, on my controllers, if I remove this, it will go to a corrupted area, like go to the heap or whatever, and everything will be crashed. Okay, so while 1 here will keep it on a good place. I think I will see, maybe I will try to let you work next time, or we can have some discussion online as I'm spending so much time. Do you like this, or should I speed up? How many of you would like me to speed up? Okay, so most of you understand well, and how many of you see that my current speed is good? Okay. What about the idle? I will keep banging you as long as you are sitting here. Okay, so we can maybe have a discussion about the speed of the discussion section and decide. Sorry? Yeah, sure, yeah. Okay, thank you guys. Yeah, let me